Question 9a. Copy and complete the table of values for y equal to 3 sin s plus 7 cos s for 0 degrees less than equal to s less than equal to 180 degrees. You have the table of values with some missing values for y, and of course you are expected to find them. B part of the question: using a scale of 2 cm to 20 degrees on the x-axis and 2 cm to 2 units on the y-axis, draw the graph of y equal to 3 sin s plus 7 cos s over the given range of values of s. C part of the question: using the graph, find the Roman figure 1 value of s when y is value of y when s is equal to 150 degrees. Value of y when s is 150 degrees. Roman figure 2, range of values of s for which y is greater than 0. A part of the question is to complete the table of values, and to do that you need to compute two things: 3 sin s and 7 cos s, after which you add together. So you take the first term, 3 sin s. This is how you do it. When s is 0 degrees, you check sin 0, and that is 0. Multiply it by 3, you also have 0. When s is 20 degrees, you check sin 20 degrees and multiply it by 3, maintaining 1 decimal point, and you have 1 decimal place, and you have 1.0. Then you check for sin 40 degrees times 3, you have 1.9, and so on. Then you come to 7 cos s. You check cos 0, that is 1 times 7, you have 7. You check cos 20 degrees, multiply it by 7, you have 6.6 to 1 decimal place. You check cos 140 degrees, multiply it by 7, you have minus 5.4. You check cos 180 degrees, you have minus 1. Minus 1 times 7, you have minus 7. You can check for others. After that, you add, because you have to add in the given function. So if you add this, you have 7.0. If you add this, 7.6. If you add 7.3. If you add this, 6.1. If you add this, 4.2. You add this, 1.8. You add this, minus 0.9, and so on. B part of the question, we plot the graph. So let's start with the given scale, 2 cm to 20 degrees on the x-axis. From this point here, origin to the end of the first bus is 1 cm. So the next one becomes 2 cm. So you give 2 cm 20 degrees. The next 2 cm becomes 40. The next is 60, and so on. On the y-axis, 2 cm to 2 units. From the origin 0 to the end of the second bus is 2 cm. You give it 2 units. What it means is that 1 cm is 1 unit. So if here is 1, you have 2, then 3, you have 4. But you have to write the figures the way the scale is given. The scale implies that one line is 0.2 on 0.2 units on y-axis and 2 degrees on s-axis. It is important that you know what one line stands for so that you can locate decimal values. Now, this is what happened. The 2 cm you have is 10 lines together. So to get one line, you divide the number of units 2 by number of lines 10, and that is 0.2. If you come here also, you divide 20 number of units by number of lines 10, you have 2 degrees. Next thing is to plot after explaining the scale and all of that. When s is 0 degrees, y is 7. So you plot it directly on the y-axis. When s is 20 degrees, y is 7.6. On the y-axis, one line is 0.2. So after 7, you have 7.2. The second line 7.4. The third line 7.6, somewhere here against 20 degrees. When s is 40 degrees, y is 3.5. Now 7.3 is between 7.2 and 7.4, the middle. That is where you place 7.3. When s is 60 degrees, y is 6.1. 6.1 is between 6 and 6.2. When s is 80 degrees, y is 4.2. That can be located easily after 4. The next line is 4.2. When s is 100 degrees, y is 1.8. When s is 120 degrees, y is minus 0.9. That is between minus 0.8 and minus 1. You have minus 0.9 there. When s is 140, y is minus 3.5. When s is 160 degrees, y is minus 5.6. And when s is 180 degrees, y is minus 7. After this, you join all the points together. Now all the points have been joined together. Always remember to include the title of the graph. It is simply the relation that you are plotting. So see, find the value of y when s is 150 degrees. You go to the s-axis. 150 degrees is between 140 and 160. Now check very well. If you decide to trace that point upward, it cannot meet with the curve. That means you cannot get y when you trace upward. So the best option is to trace that point down. You trace down to meet the curve at this point, and you trace that point to the y-axis. Notice that one line is 0.2. If you start counting from minus 4, you have minus 4.6 for y when s is 150 150 degrees. Roman figure 2, find the range of values of s for which y is greater than 0. The range occur at y equal to 0. So when y is equal to 0, it means the point where the curve cuts across the x-axis. That is somewhere here. Now look at it from that point. S is 114 degrees, but you have y is greater than 0. Now if you keep going forward, you have the values of y less than 0, but from this point, if you move backward, you have the values of y greater than 0 in this region. So from this point of 114 degrees, you move towards the origin 0 degrees. So the range is 0 degrees less than equal to s less than equal to 114 degrees. Even from the table of values, you can get this easily. Let us see that. Before we continue. Okay, from the graph we have 114 degrees, which you can obtain between 100 and 120. Now see that if you trace it down now, values of y greater than 0 are to the left. So you move back. So you move from 114 to this 0 degrees when you have values of y greater than 0. So hence from that point on the graph 114 degrees, we have to move towards the origin for you to have values of y greater than 0. Hence the range is 0 degrees less than equal to s less than equal to 114 degrees.